All right. So, I like starting out with these Padlets. Think it's important for us to try to get you to engage and talk about something. Maybe it's not about math, maybe it is. But I have a Padlet, and I'll drop the link like I did yesterday in the chat. But the title of the Padlet is it okay to lie to protect yourself? So this question is broad and vague for a reason. You can come at this question however you see fit. I only want to take about maybe 5 minutes to do so. Um, so I've started a timer real quick. We'll take 5 minutes. As I'm talking through what I've put, I'd like you to go in the chat, click the Padlet yourself, add something. Same rules applies yesterday. Keep it appropriate. I'll approve it. Um, but the question is it okay to lie to protect yourself? And then my response was, I try my best to live with integrity. And my thought is, if I have to lie to get out of a dangerous situation, then maybe I didn't have the best judgment leading up to that point. It's also important to define protect myself. So if I'm lying to protect an image, like my self-image, whether it's on social media or, if you think about influencers, if you're lying to protect kind of a facade online, that might do more harm than good. So I would say about 99% of the time it's not okay um, to lie to protect yourself. But I think there are certain circumstances that it might be okay. And so I think those really delicate circumstances are usually a very fraction of the time when you talk about the ability to lie and it be okay. But I'm curious your thoughts on it. Put something in the chat, please. I know I don't get to see y'all virtually and stuff, so this is kind of a way for me to get to know you, even though I'm not in the classroom. I've spent about a minute, 30 seconds going over this. Like I said, I'm not going to take as much time as I did yesterday. So if you would just kind of throw something in there on the Padlet, and then we'll get started. We'll get started for our lesson. I also wanted to say I didn't really leave much class time the last time we met for you to work on your assignments independently, so I don't want to be as long as I was the first time around. So I kind of want to I want to give the class as much time individually to work on your assignments. So I'm gonna try to do a little bit better job as we go into this next lesson. Less than 2 minutes. We're at 3 minutes and 30 seconds, so we have about a minute and a half to finish this, and then we'll get started talking about math. All right, so we have about 30 seconds. If you're writing or posting on our Padlet, go ahead and wrap it up. Um, 20 seconds, and then we're going to get started on math. So finish up if you haven't already. All right. Um, Also, kind of, I like to go in there and try to read some of your comments. So look and see if I comment or um, put a little emoji or something next to your post because I'm curious to know how you guys answered. But as we keep going through our lesson, yesterday we talked about completing the square. We're going to continue on with that. I think 4.01 was over solving perfect square equations. Now we're going to continue on with completing the square. Uh, this is just a quick overview. This quick video. Okay, so the first part of the lesson is going over GCF. So you should have heard of GCF in your algebra class before. GCF stands for greatest common factor. So in the question, it says, what is the GCF of the coefficients? Write your answer in the box. Let's see. So really quick. So in our first part, all we have is we have 18 and then the variable d to the fourth power. We have e minus 45 variable d squared plus 36 d. Now, GCF is just greatest common factor. And the first part of our question was, what is the GCF of the coefficients? So your coefficients are the numbers right in front of your variables. So the coefficients are those whole numbers being multiplied in front of your variables. So what is the greatest common factor? What can I take out of all of these? And I believe it's 9. So of my 3 coefficients, all of those are divisible by 9. 18 divided by 9 would be 2. 45 divided by 9 would be 5. And then 36 divided by 9 would be 4. So the way that we could write this is we could divide everything by 9. We would have 2d to the 4th power times e minus 5d squared plus 4d. And what we did is all we did was factor out a 9. So that's all that first part was asking. I believe this is 9. All right. All 3 monomials contain powers of what? So if we go back to that first part, so the original question, 18, or the original equation, 18d to the 4th power e minus 45d to the d squared plus 36d. It's asking all 3 monomials contain powers of what? So all it's asking is, are there any similarities with the variables? And if you have the little drop down box, the drop down box says it either only has variables of D, variables of E, or it has variables of both E and D. And the answer is in every single one, in every single one, there is only variable D. Let's see, so variable D, that should be our answer. And then the last part is, what is the GCF in terms of the polynomial? So um, if, let's see, back here. If, let's say that this wasn't just d at the end, but it was d squared, what we could do is we could factor out the same way we factored out a 9. We can actually factor out, we could, if it was d at 36d squared, we could factor out a d squared out of all of them. But kind of like the greatest common factor. The only thing is that there wasn't a d squared, so the only thing that we can factor out is just one variable d. So when we basically divide every single term within that equation, we divide it by d, it kind of simplifies to something else. So just like we did last time, we're factoring out a d. So this is going to be 18 d cubed times e minus 45. This was d squared. This is just going to be that variable by itself. This is plus 36. So that's what it would look like. The question was, what is the GCF, the greatest common factor? What can we factor out? And we can also factor out that 9 like we talked about earlier. So that would change that 18, 45, and 36. We can factor out both a 9d. So that would be 2, that would be 5, and that would be just 4. Remember, 18 divided by 9 is 2, 45 divided by 9 is 5, 36 divided by 9 is 4. And so this is the best way that we can come up with a greatest common factor for the polynomial. More video. So this kind of goes along with what we talked about yesterday about solving perfect square equations. And we literally discussed this yesterday about how, so for uh, the key concept is squaring a binomial results in a perfect square trinomial. In a perfect square trinomial in which the coefficient of the squared term is 1. So you have that x squared, there's a 1, an understood 1 in front of that x squared. But we talked about how if we have x squared plus 10x plus 25, we know that the perfect square of that would be halving our b, and then halving our b and then squaring it. So we have x plus 5 squared. We know that x plus 5 squared is the same thing as x squared plus 10x plus 25. So one of the next ones was x minus 4 squared. X minus 4 squared. So we know that x minus 4 squared, without having to, because the way that we figure out how it's written out is we would have to multiply those two parentheses by each other. Multiply x times x times negative 4 times x, negative 4 times negative 4. And instead of doing all that, all we have to do is we know that um, x minus 4 squared, what that's going to be is x squared. That's going to be negative 8x, and that's going to be positive 16. So when we're coming up with perfect squares, we can look at it from this perspective and know that my middle term is going to be that negative 4. It's going to be twice, 2 times my negative 4. So 2 times negative 4 is negative 8. And then I know that my negative 4 squared is going to be 16. And then like we talked about for that middle term, we know that if it's going from one way to the other, if it's going from factored form with the parentheses to the trinomial, or if it's going the other way. So if I have just x squared minus 8x plus 16, and I'm trying to get it into factored form, well, I know that my b is going to be determined from right here. So it's going to be so what it's going to be is, these are parentheses. It's going to be half of b squared. I know that half of b, so negative 8, half of negative 8 is going to be negative 4. Negative 4 is going to be 16. So that's why, like we talked about going backwards, I just have to figure out what that b is if I'm going from one perfect square in terms of a trinomial and in terms of factored form. So that's all that this is saying. X plus 5 squared is the same thing as x squared plus 10x plus 5, and then it's kind of breaking it down. You know that x squared plus 10x plus 5 squared is the same thing. And then like we talked about, you can half that b, which was 10, and then 10 divided by 2. And then if you square it, it's still going to be what you had in the beginning. We just did this one. X minus 4 squared is the same thing as x squared minus 8x plus 16. That's the same thing as negative 4 squared. Negative 4 squared is the same thing as negative 8 divided by 2, and then squaring all of that in the parentheses. One more time, fractions are a little bit not confusing, but if you have x plus 1/2 squared, we talked about that 1/2. So that middle term is going to be 2 times a half. 2 times a half is just 1. And then that 1/2 squared. So when you multiply 1/2 times itself, you get 1/4. And so that's the same thing. So x squared plus 1x plus 1/4 is the same thing as x squared plus 1x plus 1/2 squared. And then when we talked about halving that b, but when you half that b, you already get 1/2. So kind of adding to what we talked about yesterday with being able to identify like what your b is and being able to identify what your other constant would be if you're trying to finish out your perfect squares. So these two problems say find the number that should be added to the expression to make it a perfect square trinomial. So for part A, if you're trying to make it a perfect square trinomial, all you have to do is what we've been doing. So for 1 second. My place. Okay, we just went through this. Oh, okay. X squared plus 14x. Okay, so we have x squared plus 14x. We're trying to figure out what our c is. So like we talked about, the way that we find our c, if we're trying to make it a perfect square. If we're trying to make it a perfect square, we're gonna look at that middle term. We know that 14 represents our b, and we know that if we have b 1/2 of b squared, we can find the rest of our perfect square. So if we have half of 14 and then square it, I know that half of 14 is 7. I know that 7 squared is going to be 49. X squared plus 14x plus 49. That's our perfect square. This is the same thing as x plus 7 squared. For letter B, n squared minus 5n. N squared minus 5n. We're still trying to see what our c is. We're going to do the same thing that we did before. Our b, half of our b squared. Our b is going to be that -5. So we have -5 divided by 2 squared. -5 divided by 2 squared should be, when you apply your square roots, you should be able to apply it to the top and to the bottom, so it should be not negative, because a negative times a negative is a positive. This should be 25/4, I believe. Squared 5n plus 25. Yep. Completing the square. Step 1, you're going to write the equation in the form x squared plus bx equals c. You're going to add what we just did, that b divided by 2 squared, to each side of the equation, factor the perfect square trinomial, and then use the square root property to solve. So the only difference in the question that we have here is you have solve x squared minus 4x equals 32. Now before, that 32 wasn't there. So when you talk about equations, this is a different equation than just a perfect square. But to solve for your x's, in the beginning of that video, it talked about x-intercepts. So when you solve these, when you find what x is, you're finding those solutions to what your x-intercepts would be. They're also called roots. They're also called zeros. So in our question, it says solve x squared minus 4x. That's equal to 32. The way that we solve this is we still try to make it a perfect square. So we have x squared minus 4x plus c equals 32. We're trying to figure out what we can add to the left side. Remember, in algebra, when you do something to one side, you have to also do it to the other side. So if I'm trying to make the left side a perfect square, I still have to add that c on the right side. So we're going to first look at our b. Our b we know is -4. So -4 divided by 2 and squared. That's going to be -2 squared. -2 times -2 is actually 4. So this is x squared minus x plus. Now remember, because I did it to one side, I have to do it to the other side. Really quick, I know there are a lot of 4's in here. If we wrote this out, this would be x minus 2. Remember, that's what our b was. X minus 2 squared. X minus 2 squared is going to be the same thing as we have written up top. So now what we're trying to do is we're trying to solve for our x's. So if I have x squared minus 4x plus 4, all I did was rewrite that, but I can simplify the right side. I know that 32 plus 4, that's going to give me 36. And then I know that the left side, like we talked about, is going to be x minus 2 squared. That's going to be equal to 36. And this is, from this point, this is what we were doing yesterday. We would take the square root of both sides if we're going to solve for x. So we take the square root of both sides. We know that this would be x minus 2. This is going to be plus or minus 6. 6 times itself is going to give me 36. And then I can move that -2 by adding it to both sides. So if I add 2 here, add 2 here, this is going to be x equals 2 plus or minus 6. So if we're solving for what x has to be to make that equation true, this is going to be x has to be either 8, or, because 2 plus 6 or 2 minus 6, if it's 2 minus 6, it's going to be -4. Which is what we have in we have -4, and then we have 8 like we have in our notepad. Same thing for this question. So it says solve 4x squared, that's equal to 3 plus 4x. We're still trying to do the same thing. Find what x has to be to make these equations true. So in the problem, it says we're told to solve x squared is equal to 3 plus 4x. So what we're going to do is we're first going to move that 4x from the right side to the left side. So we're going to subtract 4x. We have x squared minus 4x. Remember that these two, they have x squareds and one's an x, so you cannot combine those. They're their own separate terms when you move them over. So it's if I'm subtracting 4x from the right side and the left side, I'm just left with 4x squared minus 4x. That's going to be equal to 3. Now, we talked about what's it called? Greatest common factor. The greatest common factor on the left side of the equal sign is 4. I can divide 4 out of the left side, but if I do it to one side, I also have to do it to the other side. So that's where that greatest common factor comes in. If I divide this by 4, this by 4, this by 4. That constant is going to be a fraction, but I know 4 over 4 is just 1. It's x squared. Again, the same thing here. Negative 4 over 4 is going to be negative 1. It's going to be negative 1x. This is going to be equal to 3 over 4. Now, if we're, when we talked about perfect squares, right here, we're still trying to do the same thing we were doing before, trying to create a perfect square on the left-hand side, except usually we're used to having a b. So that b right here is negative 1. So if this equals b, I have negative 1 over 2 squared. Well, negative 1 over 2 squared, if I have negative 1/2 times negative 1/2, this is going to be negative times a negative is going to be a positive. And then when you multiply fractions, you just do straight across top, straight across the bottom. So 1 times 1 is just 1, 2 times 2 is 4. And then we know that negative times a negative is a positive. So this is going to be x squared minus x. This is going to be plus 1/4. Remember, because we added 1/4, there was nothing right there. Because we added that 1/4, we have to also write it to the other side. So this is 3/4 plus 1. So the left side will stay the same, but as you can probably tell, the side on the right can simplify. 3/4 plus 1/4 is just going to be 1. And then if we're trying to solve, we just created a perfect square. We know that our b was negative 1/2. So our negative 1 squared, remember that this is the same thing as that right there. X squared minus x plus 1/4. This is going to be 1. Remember, when we solve these, you take the square from both sides. Take the square root of this side, take the square root of that side. This is just going to drop the parentheses like we talked about. And this is going to be plus. The square root of 1 is just itself. So the square root of 1 is going to be plus or minus 1. We have to get x by itself, so I'm going to add 1/2 to both sides. So x is going to equal either 1/2 plus or minus 1. That's going to be our answer. If we, this is our answer sometimes once it's simplified. If we have 1/2 plus 1, that fraction itself is going to be 3/2, 1/2 plus 1. And then if I have 1/2 minus 1, I know that a half minus 1 is just negative 1/2. This, make sure that you see this right here is a comma. So you have 3/2, comma, -1/2, and that would be our answer for those. I think we've been going for about 40 minutes. We're going to continue for about maybe 20 more minutes, and then I'm going to give you the rest of class to work on your problems either from yesterday or from today. But we should finish up relatively quick. I do not like this real world completing the square problem, so we skip it. And then we are on to the summary. Read this if you like. Just kind of questions to ponder. How do you determine the constant that you should add to the expression in the form x squared plus bx so that it becomes a perfect square trinomial? That's something that we've been doing. Once you half b and you square it, then that's how you know what your constant will be. Okay, so some more practice. We have some more practice and then review and then our assessment. All right, so it says drag the terms to the boxes to create the perfect square trinomials. So you have x squared plus 8x, x squared plus 2x, x squared plus 16x, x squared minus 4x. Squared, let's see, 8x. All right, so let me make sure. Yep. All right, so we've done this before. All we're doing is we look at those middle terms to try to find what our b is. We're going to use the equation b a half of b squared. That's how we finish these off. So I know that if I have 8 divided by 2 squared, that's going to be 4 squared. 4 squared is going to be 16. So this should be plus 16. That's how we would finish off the perfect square. For the second one, we're going to do the same thing. Our b is -2, so we have -2 divided by 2 squared. -2 divided by -2, I'm sorry, -2 divided by 2 is going to be -1. -1 squared is just going to be +1. It's going to be +1. For 16, if we have 16 and half it and then square it, half of 16 is going to be 8. 8 squared is going to be 64. Let me make sure I'm doing these right. I think we said the first one was going to be 16. that looks okay. Second one was going to be plus 1. Second one was going to be plus 64. And then the last one is going to be so if we have 4, that's negative 4. We're going to half it, and then we're going to square it. Half of 4, it's going to be negative 2. Negative 2 squared is just going to be positive 4. Yep. So for this one, still doing the same thing. Hopefully you're able to do it just by looking at it. So we know that our, let's see if this is d squared plus 7, 70. We know that this should be 7 divided by 2 squared. We talked about when it's a fraction like this and it doesn't simplify to a whole number, you can square the top, you can square the bottom. This is going to be equal to 49. 7 times 7 is 49. And then bottom is going to be 4. Yep. All right, so for this one, it's asking, there is a problem when they start working out their answers. So it says, Savion made an error when solving the equation x squared plus 2x minus 29 equals 20. So the first step that they did was move that 29 from the left-hand side to the right-hand side. And then they came up with that plus 1. So you're trying to make that perfect square. And that is correct. But one of the things that we talked about was when you do this step, you first have to get that x squared and the 2x by itself. So that's why you move the 29 to the right side. Then after you have the x squared plus 2x, you add the 1 because we know that that is how we finish the perfect square. However, when you add the 1, you need to add it to the left side and to the right side. So x squared 2x plus 1 is 2x plus 1 equal to 39. Now, like we just talked about, you do it to one side, you need to do it to the other side, and that affects your answer at the end. So this is x squared plus 2x plus 1 equal to 50. Like you saw, the next step for this is to put it in a factored form. This is going to be x squared plus 1 in parentheses. That's going to be squared. This is equal to 50. Then I can square root both sides. I get x plus 1 equal to the square root of 50. And that is then subtract 1, subtract 1, x equals negative 1 plus or minus the square root of 50. That'd be our answer. And these problems, let's see, I think this is, so that was the correct, and then like It says, in the question, you're trying to find where the person messed up. We found where they messed up, which was that second part, um, that second step of solving it. And then in the second part of this question, it asks, what is the correct solutions to the equation? Write your answers in the boxes. So we had, I think it was, this should be -1, -1, and then like we talked about, square root of square root. Oh, oh, okay, so we had that correct answer. Um, we moved that one over, and then we had plus or minus 50. It wanted us to take out right here. We can simplify the square root of 50. X equals -1 plus or minus square root of 25 times 2. We know that the square root of 50 is the same thing as 25 times 2. 25 times 2 is 50. So we know that 25 is a perfect square root. And that's what they did when they simplified. And this is -1 plus or minus 5 square root of 2, which is what they have written, and where I kind of messed up. Stay with me for 10 more minutes, and then I'll give you the rest of class on your own. We have done this already. If you're completing the square, you're going to take half of -8, which is -4. Then you're going to square -4. That should give you 16. For this one, you're going to half -7. So that should be a fraction. We've seen this before. If this is a fraction, this should be 7 over so we should have 7 over 2, right? So if we're trying to come up with the constant to find the perfect square, what do? We take the -7, we divide it by 2, and then we square it. Well, this is a fraction, but like we talked about, when we square it, we square the top and we square the bottom. So the top should be 7 squared, which is 49, and the bottom should be 2 squared, which is 4. See, enter your answers in the boxes. What we have to do is we have to find the perfect squares. T squared minus 8 squared, I'm sorry, t squared minus 8t squared minus 8t, that equal to 15, I believe. -15. All right, so we have -8. We're trying to come up with that constant. Trying to come up with that constant to get this a perfect square. So this is going to be t squared minus 8t. And then I know half of 8 is going to be -4. -4 times itself is going to be 16. Remember, if I add 16 to the left side, I also have to add it to the right side. So 15, I'm sorry, -15 plus 16, that should just be 1. When we write the perfect square, we can put it in factored form. So this is going to be what we found when we came here. This was going to be -4 squared. So this is going to be t minus 4. It's going to be equal to 1. Remember, the way we find our answers is by squaring, getting the square root of the left side and the right side. That's going to draw up the parentheses, t minus 4. That's going to equal plus or minus 1. When we move the 4 from the left to the right, we're going to add 4 to both sides. So that's 4 plus 1, 4 minus 1. T is going to be 5 and 3. 5. Yep. We've done a lot of practice problems, so I'm not going to do all of these. Quick review, then I'll leave you on your own to work on your questions. How do you feel about what you just learned? I need practice. I most certainly understand. 2.5-minute video. All right, so I'm gonna give you the rest of class to work on your assignment from the last time that we had class and your assignment this time. So I think both of those quizzes are just 5 questions each. Should take about 10 minutes each. If you have not started on them already. If you need any help with anything, let me know. Put a question in the chat if you need to. But I'll be here if you need anything. Other than that, we are done for the day in terms of math. Be respectful within the class, please. But if you need anything, let me know. We know that we're supposed to be doing our assignment So we're going to do that for the rest of class.